Okay. I've started recording the class now. Um,
Okay, I'm back. I found my notebook.
Wonderful. So, if you guys have any difficulty in listening to me, if my sound or if my voice keeps on breaking in between, just let me know. Okay.
Okay.
Can you both see my screen now?
Yeah,
Yeah.
it's clear.
Can you see the white screen now?
Yeah.
Mm-hmm.
Okay. Now, first of all, let's look at what is the difference between equation and expression. Who can tell me that?
Well, an expression an expression is just like that doesn't have an equal sign, while an equation does have an equal sign.
Okay,
Uh,
that's
expression is just like stated thing like that can be reduced or increased, and equation can like be solved.
yeah, yeah. This one is expression. This one is
Mhm.
equation. Yeah.
Yeah.
Now, since we are talking about expression, let me do a quick recap of what are the things that we have seen in the past. If let's say I'm looking at this as an expression, what is this
Mhm.
called apart from expression?
Um,
Have you heard of something called polynomial?
Polynomial. Yeah, I think I've heard of that from my other
Multiple.
math class.
Yeah.
I think it's two
Yeah.
or more.
Yes, so you're saying something.
I think it's like multiple or something.
So it's called polynomial. So basically, if you look at any equation, this is called one term. This is called another term. This is called another term. There are three
Yeah,
terms here. Okay.
yeah.
So if there is only one term, let's say if I'm talking about 6x squared or 5x or 9, okay, these are
Mm-hmm.
individual expressions, okay, with only one term into it, okay, only one term. Term meaning something which has a as a coefficient and a variable, okay, with some power, okay. So
Yeah,
this is called coefficient with which you multiply. This is the variable, and this is called the exponent or the power.
yeah.
Yeah.
Mhm.
So here this is one term. This is another term. This is another term. In this expression, if
Mm,
you see three terms. This is one term. This is another term. This is another
Mhm.
term.
Third term.
yeah,
For the sake of simplicity, you can say the terms are separated by the operands or the plus minus sign or multiplication sign or division sign. Okay.
yeah,
Yeah.
So this is one term, this is second term, this is third term. If an expression has only one term like this, it is called monomial. Okay, monomial expression, you can say. If
Let
it
me
ha-
write down. Okay.
if you have
Mono.
this two terms, that is called binomial expression. Okay. And if you have an expression like what we were seeing before, three terms, that is called trinomial expression. Okay.
yeah,
So
So
here,
is it trinomial? Trinomial?
yeah.
Okay.
So monomial, binomial, trinomial. And when you have more terms, anything more than one, okay, those are called polynomials. Poly, like we saw while studying geometry, we said okay, triangle, quadrilateral, pentagon, or every shape that has more than one side, that is called polygon, right?
yeah,
So triangle is a
Mhm.
polygon, quadrilateral is a polygon, pentagon is a polygon. Likewise, poly stands for many. So polynomial is a term used for expressions where you have more than one term. Okay.
Mhm.
Interestingly, even
Mhm.
with one term, people call it polynomial. Okay, that's how we have got used to it. Okay, but in absolute terms, any expression which has more than one term is called polynomial expression. Okay, that was just the prelude to what we are going to learn today. Okay,
Mhm.
Yeah.
Okay.
any doubt so far? No.
No.
Okay, Mitran, you're fine.
Yes.
Okay, now let's look at expressions. This is one expression.
Mhm.
Here, you can also read this as, what is the variable here?
X.
Only x is the variable. Rest all is fixed. Okay.
Mhm.
You can
Yes.
have expressions with one variable or multiple variables. Okay.
Okay.
If you have expression like 2x squared minus 6xy plus y squared, this is also an expression, but it has two variables. Yeah,
Mhm.
x and y.
Mhm.
So in this chapter, or whatever we are going to learn today, we are going to focus on primarily the expressions, the expressions with one variable for now, and we'll gradually go to two variables and more as well, right? But before we do that, um I'm just thinking, shall we look at the entities also? Okay, let's recall some of the things that you guys have learned before.
Mhm.
Do you know what is this called?
Mm, Um,
A linear equation. Oh, Oh, I think this is distribute.
This is called, these are
Oh,
called identities actually. Okay, they
oh
are
uh,
yeah.
named,
Please, I
right?
forget.
let me write that down.
What is that?
Let me write that down.
Yeah, please go ahead. I mean, it's there on the YouTube video as well, so you can watch it later and you can note it down. But these are called identities, right? X plus y whole square is equal to x squared plus 2x squared plus y square. X minus y whole square is x squared minus 2x squared plus y square. And you can find that out. I mean, I'm just writing it down because this is something that you will use day in day out in algebra, right? I'm just capturing it here. If you say x plus y whole square, x plus y whole square means x plus y, come on, into x plus y, right? And you will say, okay, let me
You there? Your screen's
multiply
frozen.
x with x and y, and then y.
Yeah, we can,
It's just
Okay, can you
clear.
hear me okay?
It's not that clear.
I can hear you clearly, but you just lagged. Your
Okay,
screen froze like a few seconds ago. Yeah,
Yeah,
it's
okay,
fine.
is it okay now?
it's clear.
Okay. Okay, so x plus y whole square, I'm just trying to, kind of break it down. Okay, so if you are talking about x plus y whole square, how is that? X plus y into x plus y, right? If you multiply x into x, what it becomes? X squared. So likewise, we talked about x plus y whole square, right?
Mhm.
So that means x plus y into x plus y. So that's what we are trying to do. So we are trying to break the brackets. Okay, so first it
Okay.
will be x multiplied by this, then plus y multiplied by this, right? That's how I'm breaking it. If you see this line, right?
Okay.
And
Yeah.
then you break it down. So x into x, here x into x makes it x squared, plus x into y makes it xy, plus this one now y into x, you can write it as
Why?
yx or xy. Yeah, and then y
Yeah.
into y becomes y squared. So this, you see two times of this one, x squared plus y squared. So that is how it was. X plus y whole square equal to x squared plus y squared plus 2xy. Okay, I was just telling you guys how that identity holds any meaning. If I just tell you guys that okay, this is the formula, memorize it, you will not learn. That's why I was trying to prove this to you guys saying, okay, x plus y whole square equal to this much is because we are just doing simple mathematics to break it down. Okay.
Okay.
Similarly, if I said x minus y whole square equals x square minus 2xy plus y square, this is something you will end up memorizing, or I have kind of memorized it after studying this 35 years ago because I did enough maths with this. Okay. Now, why this formula exists? I know that x minus y whole square means x minus y into x minus y, right? Like x
Yeah.
square is x into x. So x minus y whole square is x minus y into this. So now
Yeah.
I can make the
Mhm.
bracket. I will say x into x minus y. Then I have a minus sign. Minus y into x minus y. And then I'll
Mm.
multiply and get what I was saying here. So see, this is x into x becomes x square minus x into y becomes xy minus xy. Here it's minus y into x. So again minus
This is
y.
what?
Yx and xy will be same, right? You write 2 into 4 or 4 into 2. It's the same, correct?
Okay.
Yeah. And then
Mm,
minus into minus becomes plus, y into y becomes y square. So now you see y square and xy square is there. This and this are there. And this minus xy and this minus xy. It's like one banana and one banana becomes two banana here.
yeah. Yeah.
Wait, is that an equal to symbol between those expressions?
Uh,
No,
uh,
I just overdid that. I was just since I was explaining that to you guys, I just
Uh,
yeah. So see, this is the thing. Here also, I probably while trying to explain you guys, I just put one extra line there. So x minus y into x minus y, right? So I am just splitting them. So x into this value minus y into this value. That is how I'm breaking the brackets, right?
mm,
mhm.
Are you guys clear about what I'm doing right now?
yeah.
Yes.
Okay. Similarly, x minus y into x plus y will be x square minus y square. Same thing here also. This means x into this minus y into this. So it will be x into x plus y. And then you have a minus sign here. Again, see, I did the same mistake, right? I put an extra line here to confuse you guys. So here it will be minus y into x plus y. Now you don't know the maths.
Which is it? Is that x into x plus y?
Yes. So
Okay. Okay.
yeah, see here, I have x minus y into x plus y, right? So I'm breaking the two brackets. Okay. I have a minus b into something. Okay. So that means a into that something minus b into that something. Okay.
Mhm.
So x minus y into something. That means whatever is the value of x minus y is to be multiplied by this whole thing, x plus y. So I'm just splitting it here. So x into this value minus y into this value. So let's say tomorrow you have a situation. Okay, let me not do this one. You if you have this, if you have to do 2 minus 6 plus 4. Okay, if you have to multiply this with 2 plus 6. Okay, what will you do? You will find out the total value of this, find out the total value of this, and multiply
Then
them.
multiply them.
Right?
That's
Or yeah, or sorry, Shiva, you were saying something.
no. I just got the answer.
So okay, I am one bad teacher who cares very little about the answer. Okay, I'll tell you why. Because answer is something that you will get for sure. I have zero doubt about it. But what we need to make sure is we always focus on the process part of it. Because
Mhm.
questions can change, answers will change, process will not. So if you get the process right, the chances of making mistake is less. Okay, then it's all a matter of practice. Okay, So I'm not
Yeah.
discouraging you from having the answer, but I don't get excited by hearing the answer. I'm more excited by hearing the process part of it. Okay. All right.
Yeah.
Let's go here. So if I had 6 plus 4 multiplied by this, as I said, as Mitra also confirmed, that I will find out the value of this multiplied with this. Or second thing is, I will say, okay, fine, I don't like doing bigger maths. I will deal with the smaller things, meaning I can break it down and say, okay, this equals 2 into 2 plus 6. Then pick up the next number, minus 6 into
Where
2 plus 6.
where two
Yeah.
from? Where'd you get the two from? I don't see any exponent. Where'd you get the two from?
Which one?
From here, from the bottom. Where did you get the two from in front of the equation?
Oh, I think that's the
This is
second one.
this 2 plus 6. See, I'm trying to multiply 2 minus 6 plus 4 with.
I think I might know what you're doing. I know what you're doing. I know what you're doing. You can continue on. I know what you're doing.
Okay. Now I'm just splitting it, okay? And same thing can be used for x, y, whatever it is, okay? So what I'm doing is I'm breaking it down. So 2 minus 6 plus 4 multiplied by 2 plus 6. I'll pick the first number, 2 multiplied by this value, okay? Then look at the second one, minus 6. I'll say minus 6 multiplied
You froze.
by this.
Are you there? Yeah, because
Yeah,
we were
no.
talking a bit.
Okay. Is it okay now?
Yeah.
Yeah, it's fine.
Okay. So I'm just repeating myself. So what I did was whatever I had in two brackets, I picked one side of the bracket and picked up each element one by one and multiplied with the whatever we had in the second bracket. Okay.
Okay.
Yeah.
Mm,
So
Mhm.
if
yeah.
I say I my wife and my two kids, they will eat something. Okay. I can say I will eat something, my wife
Okay.
will eat something, my kids will eat something. Or I can say I, my wife, and my kid all together and then multiply that with something. Right? So here I'm breaking it down. I'm saying, okay, I, my wife, and my kids. And my I will eat something, my wife will eat something, my kid will eat something. That's what I'm doing here, as you can see. Yeah.
Yeah.
Mhm. Yes.
So that is how you break it. So now you if you go back to what we were trying to do here, x minus y into x plus y. Same thing. I fixed one side of it. Okay. One bracket I fixed. And then I picked up one number, multiplied by this bracket, pick the second one, multiplied by this bracket. That is how I'm kind of exploding the brackets. Okay.
Yeah.
So
Yeah.
this way I can say, okay, I something, my wife something. Done. Yeah.
Mhm.
And now I can multiply. I mean, I can do simple multiplication, right? We know how to break the brackets. So this multiplied by this. Okay, x into x is x squared. X into we have plus sign, so I'll write a plus. X into y is xy. Here it's minus y into x. I can write this as xy or yx. Both ways is okay. I have minus sign, so I have put a minus here.
Mhm.
On the last one, on the last number on the bottom, is that an X or a two?
Which one here?
The yeah, the X squared plus XY minus. Is that
That's
XY or 2Y?
Xy.
Okay.
Yeah, because see, I'm just let me go step by step again. So that is where I put my energy. Okay, I will do that sum again and again so that there is no doubt about what I'm doing. Okay, now let's do it one more time. So here I'm just breaking this bracket now. So I take the first number, first value x multiplied by this. That becomes x squared. Now I have a plus sign. I'll write a plus sign. X into y, xy. Yeah. Then I'm going
Mhm.
to this bracket is done. This one is done now. Now I'm going to the other one. I have a minus. I wrote minus y into x. That is yx or xy. Same thing. 2 into 4 or 4 into 2. Same thing, right? Same way. Xy. Now minus y into plus y. So minus into plus becomes minus. Y into y becomes y squared. Yeah.
Yeah.
So 1 minus xy, 1 plus xy cancels out each other. And that is how it becomes x squared minus y squared. So all the
Mhm.
x into y, x plus y into x minus y becomes x squared minus y squared. Same way, if you say a plus b into a minus b, that becomes a squared minus b squared. So these are three identities that you will always use. That is the backbone of algebra. And there is no assumption here. We just derived it, right? So
Yeah.
x plus y, and I'm pretty sure you would have come across this before and you would be knowing it. I'm just stressing on that, saying that this is something that you will end up using pretty often. Okay. Till you have to deal with maths, this is not going to go away anywhere. Okay.
Mhm.
Okay.
So I will keep doing it till you guys get bored or till you memorize it for yourself. Okay. So these are the three
Yeah.
identities. Now, now let's go back to equations and expressions. So far, any doubt?
I don't have any doubts so far.
See what's
I'm
up?
good.
You're good.
Yeah. It's yeah.
Okay. Now let's look at somebody saying an expression, a polynomial expression with a variable x equals x squared minus 3x plus 2. This is just an expression. It's a polynomial expression because there are multiple terms. Okay. I
Mhm.
just put that as P as a symbol, saying this is a polynomial expression with a variable x. So I can write like this also. So tomorrow, if somebody says, write a polynomial expression with x squared minus 3x plus 2. So you can either write this as expression, say, okay, my expression is this, or you can also say a polynomial expression x with variable x as x squared minus 3x plus 2. It's up to you. I mean, you guys can choose how you want to represent or write that expression. Okay.
Okay.
Mhm.
Now, when you have an expression that just gives you a, no, a collection of terms which represents that. Okay. Now, let's look at one more thing. If you're looking at an expression, what is the exponent of x here? What is the power of x here? What is the power of x or exponent of x here in case of this?
One,
In case of this,
two.
2, right? So
Uh-huh.
if you're looking at at a polynomial expression, okay, like this, let's say this is the polynomial expression, okay, with three terms, with one variable. Here, what you see, x has maximum exponent as 2. Here it is 1, right? This is
Mhm.
called this exponent, the maximum power of the variable or the maximum value of the exponent for the variable is called the degree of of the polynomial expression. Okay. So
Okay.
you can also say if I have a polynomial expression like this, okay,
Okay.
the degree here is 1 because the maximum power on the variable is 1. If I have a polynomial expressions like this, here what will be the degree? It will be 3. You have to always look at the maximum exponent for the variable. So here it's a polynomial expression of degree 3.
Yeah.
Yeah.
If you have a polynomial expression with variable as y, what is the degree of this polynomial expression?
One.
No.
Trinomial.
Oh,
2.
two.
2
Yeah.
y minus y plus 8.
You're asking about what what nominal is it?
What is that?
I thought you were asking what I thought you were asking what binomial, trinomial, and polynomial is.
No. So we have started talking about the degree part of it. Okay, for any polynomial expression.
Oh,
So
okay.
see, first thing we learned was what is a polynomial expression. Meaning, if it has one term, it is called monomial expression. If it has
Yeah,
two terms, it's called binomial expression. And
yeah,
again,
and
okay.
mhm.
Now the thing here is, if I look at two expressions, let me clear it out. If I look at this expression and this expression, both are monomial because it has only one term. Okay.
Mhm.
Okay.
Mhm.
But in this case, what is the degree of this monomial expression? 1. Because the power of x is 1. Here, what is the degree of this monomial expression? It is 7. Because the variable's exponent value is 7. So there's a difference between degree and the type of polynomial expression. Okay.
Yes.
So that's what I was saying. So if let's say you have an expression like this, okay, what is the variable here? X. What is the maximum power of x? That is 2 here. Here it is 1, it is 2. So the degree of this polynomial expression is 2 because this is the maximum power. Okay.
Yeah.
If you have, I'll tell you guys what is the interesting part of the boring stuff that I'm sharing right now. Okay. If you have something like this, what is the degree of this polynomial expression?
Three.
3. You are looking at the maximum value of the exponent for that expression. Okay. So if
Okay.
even if you
Wait,
have
I have a question.
Mhm.
So basically, what do you mean by maximum? So can we add the both exponents?
No, you don't have to. See, that's why I gave the next example. I have 3x cubed plus 2x squared minus x minus 7. Is this a polynomial expression? Yes, because there are
Yeah.
four terms. One, two, three, four terms. Okay.
Mm-hmm.
What is the degree of this one?
Is it
Degree
three?
is 3 because you are looking at all the variables here and you have only one variable, that is x. Here the power is
Mhm.
1, here the power is 2, here the power is 3. You are
Mhm.
going to pick up the one which is the maximum power. So that is 3. So the degree of this polynomial expression is 3. Now you look at this polynomial expression as well. Here also it's a polynomial expression because there are 1, 2, and 3 terms. And
Mhm.
the variable is also x, like this one. Okay. And degree is also, here the degree is 3, like this guy. Correct? This
Yeah.
guy's
Mm.
degree is 3. Here also the degree is 3. The maximum power is 3. Here it's 1 and 3. You will pick up this one. So this is your degree is 3. But then there's a difference between this expression and this expression, right? That this one
Yeah.
has
Yeah.
got 4 terms, this one has got 3 terms. Yeah.
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 Now I'll tell you why I was stressing so much and boring you guys with the degree. Okay. Now, if you have a polynomial expression with degree 1, okay, if the degree is 1, degree, oops, I need to learn writing also, man. I have so much of computer is not good. Okay. 1 is degree. I'm talking about a polynomial expression with degree as 1. That means I'm talking about something like this plus 7 or whatever number. Okay. Or I'm talking about
Mhm.
8y minus 2. Something like that. Okay, these two could be
Okay.
different. Here I'm saying 1 degree 1 because the power maximum power of the variable is 1. Okay, so if you have a polynomial expression with degree 1, that is called a linear expression or a linear equation. I mean, if you put equal to this becomes equation, right? So this is any polynomial expression with degree as 1 is called a linear expression. Okay,
Yeah.
and
Yes.
that is what translates into a linear equation in future. So once we learn the graph and plotting of graph, or plotting no, a graph with a line equation, you will come across this. So if there is a polynomial, meaning an expression with more than one terms, and the degree is one, meaning there is no square, there is no cube, there is no power 4, it's only power 1 for the variable, that becomes a linear expression. Okay, now
Yeah.
if the
Yes.
degree 2, if an expression with degree 2, that means we are talking about something like this. This is called binomial expression. Okay, so no, not binomial, sorry, quadratic. Yeah, it's called quadratic equation, quadratic expression. Okay, so when you solve the formula for no for the quadratic equation, this is the base, meaning this is a polynomial with degree 2. That's why it is called quadratic expression. If there's a formula with degree 3, that's called a cubic expression. Okay, so linear, quadratic, and cubic. So I have confused you guys enough. Let me do a recap of what we have learned so far. Okay, let's go slow.
Yeah.
Okay,
Okay.
so first thing we learn about an expression. What is expression and what is equation? That part is clear, right? No doubt.
Yeah.
Expression with an expression is something which has constants and variables together and with different degrees or different exponents. So this is an expression. This is also an expression.
Yeah.
Mhm.
This is also an expression. So if there is an expression with one term, that is called monomial expression. If it has two terms, it's called binomial expression. If it has three terms, it's called trinomial expression. Or things which has more than one term, in general is called polynomial expression. Up to this much is clear, right?
Yeah.
Now, when we talk about a polynomial expression, we also look at what is the degree. And degree of a polynomial expression is nothing but the maximum power of the variable. Okay.
Okay.
If you're looking at this expression, the degree of this guy is 2 because this is the maximum power. If you're looking at this expression, here also the degree is 2 because 2 is the maximum power. If you are looking at this expression, the degree is 1 because 1 is the maximum power, okay, of the
Yeah.
variable. And if we are talking about any polynomial expression with degree 1, that is called linear polynomial expression. Okay. If you are
Yeah.
talking about any polynomial expression with degree as 2, that is called quadratic polynomial expression. If you are talking about any polynomial expression with power as 3, that is called cubic polynomial expression. And these are terms that you just need to kind of inject in your brain. You will not deal with these terms very often, but if you come across a term saying, okay, a quadratic binomial expression, that sounds very cryptic, very scary, but actually it's not. It's just about understanding what it means. Okay,
Okay.
yeah.
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 So these are the things that we have learned so far. So now let's try, and then we learned about the identities. That is where we kind of look through the formula for x plus y whole square, x minus y whole square, and x plus y into x minus y. These are the backbones of any algebraic thinking, algebraic equation, anything to deal with algebra. Okay,
Mhm.
Yeah.
and those are called identities. And we also saw how x plus y whole square is x squared plus 2x plus xy plus 3. So we did that. We don't have to believe ourselves. We just did it, right?
Yeah.
Now, now let's move a little bit away from expression and move towards equation. So let's an equation. Okay.
It's froze.
Are you there?
Your screen's froze.
Mitran and Srivastav, can you guys hear me okay?
Yeah, we could. You just froze for a
Yeah,
moment.
the network was not good.
Yeah, network is a little patchy of late. I know. I think there has been a lot of virus attacks for AT&T, Spectrum, and all. They have been grappling with that problem, and that's why last couple of weeks I'm seeing network goes on and off in between. But
Mhm.
I hope you can hear me okay now.
Yeah, we
Yeah.
can. It's
Okay.
better.
No,
So between expression and an equation, the major difference is that there's an equal to sign. If there's an equal to sign, that makes it equation.
yeah.
Or other way to look at it is that an expression just gives you a combination of terms. If if you make the value of an expression as zero, let's say if there was no zero here, this was an expression. I can put a zero to make this an equation, and this gives me the value of x for which this expression will be zero. Okay,
Yeah.
and that is why it is called zero polynomial also. And again, there has been too much of terms today, right? So if you remember it or you don't remember it, it's okay, it's not going to hurt. But I was just telling you, because no, you'll keep hearing these terms while solving the sums, and you should not get worried about those things. Okay, so let's not worry about the zero polynomial right now, but let's look at this expression. We converted that to into an equation, and the purpose is it helps us solve or find out the value of x for which this expression will be zero. Okay, now
Mm.
how do you solve it? Who can tell me what are the values of x from this equation?
There's x squared and
X
x.
squared and X.
What is that?
X
X
squared and
squared and
x.
X.
Maybe one by one.
X.
Value of x, huh?
X squared. I mean 2.
Okay, now I think let's try solving it. Okay, so here something is zero. That means this value minus this value. There's some value of x. If I put that value of x here, it'll give me total value as zero. Okay. How do I find that out? So now when you look at expressions, there's one thing that you have to recall from your previous classes, that is called factorization. Meaning you have to look at ways to factorize things or make them as multiples of each other. Okay, if I can convert this into something into something, okay, then it's easy. I mean, if I, let's say I get two things x, this, I can break this into two parts, saying okay, this equals something like a into b. Then I can say either a is 0 or b is 0, so that's why a into b becomes 0. Okay, so now let's look at how I can factorize this. Not very difficult. We'll always look at what is common between these things. Okay, so if you look at this side, we are just trying to make this as something into something. Okay, so let's find out if there's something common here. What is common here in between the two is x. This one also has x and this one also has x. Yeah,
Yeah.
if I take an x as common here, what is left in this guy? It becomes 3 into x because 1x came out. Yeah.
Mm-hmm.
Mm-hmm.
Are you guys with me so far?
Yeah.
Yeah.
And if I take, since I've taken x out, what this guy is left with now? 5.
Yeah.
So I just took the x out because that was common in both the things, right? So it became
Mhm.
x into 3x minus 5. Now, what this means, either x is 0 or this value is 0. That's what is leading to the answer overall value being 0, right? Either x is 0 or this value is 0. One of the two is 0 actually. Okay?
Mm.
That is
Mm-hmm.
why the overall value is 0. See, if let's say if I have 100 and you have 0, okay? Then multiplying your value with my value becomes 0. Or it's the other way around. Let's say I have a 0 or you guys have 100. Saying let's multiply our numbers becomes 0. That's what is happening here. One of the two is 0. That's what is making it 0. If it was not the case, then there was no ways for it to be 0, right? If I this guy had 2 and this guy had 5, this would have been 10, not 0, right? So one of the two is 0 actually. Correct? Agree?
Yeah.
Yeah.
So here's the answer. Now look at this. Come on, come on. Okay. Hmm. So that means either x equals to 0 or 3x minus 5 equals to 0. One of the two is 0. So one possible answer is x equals to 0. If you put x equals to 0 in this expression, what it becomes? 3 into 0 square is 0. 5 into 0 is 0. 0 minus 0 will be 0. So we got one answer for x. Okay. Now 3x minus 5 equals to 0. That means 3x will be equal to 5. We are making this guy go from here to other side of the equal to sign. So
Mm.
minus becomes plus. So 3x equal to 5. That means x will be equal to 5 by 3.
Mm-hmm.
Did you guys
Yeah.
follow what I did?
Yeah.
Yeah. We'll go right down.
I will I will write it here again. So
Okay.
this is what I had. X into 3x minus 5. When I took the x common out, my equation became like this. That means either this part is 0 or this part is 0. So let me take the first equation when x is 0. There's nothing to do. It comes with a simple thing. X goes to 0. Very simple. 3 and the second situation is 3x minus 5 equals to 0. Now, remember one thing. Plus becomes minus, minus becomes plus. Multiplication becomes division, division becomes multiplication. When you make things traverse across the equal to sign. Whatever you have as plus, that will become minus or vice versa. Okay. Whenever you make them travel across the equal to sign. Okay.
Yeah.
If you
Yeah.
have something as multiplication, that will become a division. If you make that guy travel across the equal to sign or vice versa. Okay. Now let's do that. So here I have a minus sign. So I'm trying to find out what is the value of x. So I need x on one side and everything else on the other side of equal to sign. That's what it will be, right? X equal to
Yeah.
something. So I'm step by step doing it. 3x minus 5 equals to 0. That means I have to knock off this guy from this side. This guy doesn't belong this side of the equal to. Okay. So I made this guy to go this side. So it became 0 and minus became plus, like I said, right? So it's minus. You are making this guy go outside the other side of the wall. That's how minus becomes plus. So 0 plus 5 is 5. Yeah.
Mm.
You got 3x equals to 5. When you said 3x, that is 3 into x. Yeah.
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 So here, whatever is multiplication will become division by going other side, right? So if I'm just trying to keep x on one side, meaning I'm trying to get rid of this 3. Here it is into, it will become division. So it'll go this side. Okay. Or if you want to play like a child, whatever you have as multiplication, you can just make it go down. If it is here x by 7, it'll go up. So it moves in a, a diagonally, opposite direction actually. So from above it will come below. If it's below, it will come above. So, see this. If I have like this, x by 3 equal to 5. Okay, so it is here down, it will go up. Okay, so it will become x equals, this goes up, so 5 into 3. Okay, if it was, let's say, if it was like this, 3 into x equal to 5. So if I have to keep x one side, this guy is above, it comes below. So it will become 5 by 3. From here it comes down. Okay?
Yeah.
So you can think like a sword, okay? Two swords crossing each other, okay? And the sword, center of the sword is the equal to sign.
Or
You
you could also divide both sides by 3. That's what
you
our teacher told us.
That is the way they do it, okay? That is the way they do it here in the US, right? 3x equal to 5, so I'll divide by 3 here, divide by 3 here.
Hmm.
that
And
is
then
that is
you and then you cross out the threes out. Then x would equal to 5/3.
Correct. So that is how they do it. I mean, there's nothing wrong with that. I mean, you can choose the way you want. I see, look at this. If I have 3x equal to 5, I can write a 3 here, write a 3 here, perfectly fine, not an issue. I am just trying to keep it clean. Okay.
Okay.
Yes.
Otherwise I will have this extra thing. Some extra real estate is being used on the piece of paper, right? So it's up to you guys. I mean, whatever you guys are comfortable with, you can do it. I'm just, if I have three numbers, I'm dealing with three numbers and closing it there. But if you're comfortable doing it this way, that is also fine. There's nothing wrong with that actually. Okay. The only problem is if you're dealing with, let's say, x equal to 27. Okay. If this is the thing, then if I say, okay, fine, I will divide this by 3 and 9 here and 3 and 9 here. That will make it more, make it take more space. I will do it one shot. I will say 3 into 5 into 7 into 9. I just kept the x one side. And then I know that, okay, this is 27. So I can write 27 as 3 into 9. 3 into 9, right? And I can do tic-tac-toe one side. 9, 9, 3, 3 gone. So this becomes 1 by 7 into 9. Or whatever it is. Yeah.
Yeah.
This is 5. Okay. So basically, again, don't go by what I'm saying. Do the way you guys are comfortable. Ultimately, we have to get the right thing in the right way. Okay. If you think just dividing both ways is easier, go ahead and do it. If you think this new approach helps you save some time, go and do it. Okay, that's perfectly fine. So this is where I will stop. I don't want to go deeper into it. You guys have been hearing me for last 1 hour non-stop, and I know we dealt with lot of terms, lot of interesting terminologies. You heard about polynomial, binomial, trinomial, degrees. Then you also heard about the linear expression, quadratic expression, and then cubic expression, right? And then we were trying to solve this uh, for getting values of x by solving uh, the expression. And we also did a recap of the entities. So in the next class also we will spend more time. Let me stop recording. In the next class we will